and whiteboard. Okay. Okay. Let's do the first question. The first question is like, just a second. Oop. Something is coming to my screen. What's that? Sorry. Here we have a surface, and there's a step on the surface, and we put here a sloped member like this. Okay, and there is a rope. It's coming from here. This is a straight line. I can't draw it like a straight line. Oh, maybe it mixed you up. I can do it like this. Yes, I can do it. That's better. And also here, there is a man standing, carrying this rope. And length of this member is 3 meters. And this is the member we have. Weight of the member is 10 kilogram. What we have more here, we have the angle, which is 45 degrees. This angle is 30 degrees. Okay. This is point A. Here, the question is, under all these given data in the sketch, this system is in balanced position. So what is the tension force? On the rope, which is T, let's say that T. And what is the support reaction? Support reactions at point A. Okay, this is the question. Yes, that's better. Now what we have here, we have a member and rope. As you can see, this is in balanced position. So if this is a balanced position, we can find the tension force on the rope, and we can calculate the reaction from the ground, because here there is a step, this member stuck to this point, so it gives down a vertical support, vertical load, and also it gives a lateral load. Depending on the force and reaction principle, the ground, this part, gives our structure reaction forces. So let's draw the free body diagram beforehand. Free body diagram. Here I have a member, as you can see. This is our member. On this member, what we have? We have a weight. Weight is acting on the midpoint of this member, right? So this is the weight, goes down. W is 10 kilogram. And what we have more, we have support reactions. by the way, before that, let's draw the rope here. Here we have T with the angle of 30. And we have more reaction forces. One is vertical here. One is horizontal. Okay, this is H. So what we know, this angle is 45. And if this system is in balanced position, how do we define the equilibrium or balanced position? We have, you can remember, we have three equations. What are they? Let's write them. You have to know this. This is really basic. Total X is 0, total Y 0, and total moment in any point is 0. This is the equilibrium definition, right? You know this. Okay, we are going to provide all these three equations in our system. Let's write the total X equals 0. So here, what we have in the horizontal direction. When we look at this sketch, we have, this is our free body diagram. Remember, free body diagram. So what we have here in X direction, we have HA here. And also we have T here. This is not in X direction, but it's, if we resolve this T to its perpendicular components, we are going to see there will be a horizontal component. So let me clear T here and write T here. That's better. Now let's resolve this force with green. What we have, this is the horizontal line. This angle is 15. So there will be a component like this, T times what? Cosine 15 here. And okay, this is the horizontal component. Let's do the vertical one. So we have one more vertical here, which is T times sine 15. What we did here, we have only one inclined force on the system, which is T. We convert it, we resolved it to its perpendicular components. That's it. It's basic. Cosine, and we are using trigonometry here, cosine and sine. Please be careful about this cosine and sine. If you mix them up to each other, you're gonna get a wrong solution. So this is not about this course. You know this, what is cosine, what is sine. So that's why I'm not deeply explaining all these trigonometry issues. Okay, let's write the horizontal equation. Let's look at the HA. HA is in the positive direction, positive X direction. HA, it's positive. Let's have a look. T cosine 15. It's in the negative X direction. Remember, we are doing a vectoral calculation. That's why we have to consider the directions. Okay, so minus T cosine 15 equals 0. Okay, this is the first equation we have. Okay. Then, do we know HA? No. Do we know T? No. Okay. Keep this equation here. Let's do the second one. The second one is here, total Y. Let's write the total Y equals 0. What we have in the vertical direction? We have vertical A, weight of the member, and the vertical component of this T, the tension force. Okay, let's write the equation in between these numbers. Vertical A in positive direction. That's okay. So then what we have in negative direction, we have 10. And then again in negative direction, I have T sine 15. I have one more equation here. Can I solve all these numbers? No, at the moment. So let's keep this. This is the first equation. This is the second equation I have. Let's write the third one. Total M A equals 0. Why MA? Here, the member stuck to this step. This point is my support point. So this is not a fixed support. It's only, it's like a pin support here. That's why it has two components, two unknowns, HA and VA in the sketch above, as you can see. So we have total MA equals 0. Remember, if there is a pin support, the moment is 0 at this point, at this support. So we are gonna write this equation. Let's write the total MA equals 0. Here, by the way, let me correct this point. I'm sorry. Yes. What we have? I'm gonna check the dimensions here. This point, yes. What we have? We have this weight, 10 kilogram. Let me change the color. 10 kilogram times distance to this point. But what kind of distance? Perpendicular distance. The perpendicular distance is here, right? So what was the total length of this member? 3 meter. Half of this member is 1.5 meter. Let me change the color. This is 1.5 meter. So this is the hypotenuse. We have the angle. This dimension is 1.5 times what? This is the cosine component. Cosine 45. So this is the distance. So 10 times this distance gives me moment. Let's write it here. Change color. 1.5 meter times cosine 45. Okay. This member turns the system in this direction. Right. This is my assumption, positive direction. Now, what we have T here, T here. You can use these components, the perpendicular components. That's okay. And also you can use this method. For example, you can complete this dimension to a perpendicular triangle. So what I need here, this distance. because this is the perpendicular distance to that point. Here is, 3 meter. So this part is 3 times sine 30. We are going to use this 30 here. Please make more practice about these sine and cosine issues, how we can convert a length to its neighbor or its cosine or sine components. Please make more practice. Here, minus t times 3 sine 30. This is distance, as you know. This is force times distance equals 0. This is the third equation. So if we have a look all these 3 equations, as you can see, we can solve firstly the last one, the third equation, because as you can see here, there is only one unknown. The unknown is here, t. Okay, this is unknown. All other numbers are here, as you can see. So if we solve this equation, you can do it. T is 7.07 kilogram. If we know T, we can solve all other equations, because let's jump up the second equation here. As you can see, in this equation, okay, there is one equation. There are 2 unknowns in this equation, but we know this T anymore, which is 7.07. If we put this number here in the equation, we are going to get only one unknown. So if you solve this equation, VA is, let me check the VA. What is it? Yes, this one. Remember, you are going to do all these calculations with your calculators. Okay, that's why when you take a look, sine 15, other stuff, they look very complicated, but this is not really complicated. If you have a calculator, all these calculations are really easy. Okay, we have VA here. Let's jump the first equation. In this equation, we have 2 unknowns. One of them is T. We know it. Put it here in place in this equation. So get HA. What is HA? If you solve this equation, you're going to get this 6.83 kilogram. So what we did here, the solution is this. HA, VA, the reaction means all the components, horizontal and vertical, HA and VA. And the question asks tension force on the rope, which is T. Okay, basically what we did here, we did firstly a free body diagram to see all the forces on a sketch. After that, we have an inclined force. We don't like to use the type of inclined forces. We generally convert it, resolve it to its perpendicular components. So we did it, as you can see in green at the top, T cosine 15, T sine 15. After that, we applied equilibrium equations. That's it. We write total X, total Y, total M0. We get 3 different equations. And okay, we have some unknowns in these equations. At the end of the day, the mathematical logic is what? If you have in these equations, we have 3 unknowns, but at the end of the day, we have 3 equations. If you have 3 unknowns and 3 equations, you can solve this system, this equation system. We did the same thing. take a look here. We have 3 equations, 3 unknowns. We solved one of them first, and then the first one is T. Put it in place in the other equations and solve them, get the results, HA and VA. That's the basic explanation of this question actually. Okay, this is the first question, and I'm gonna write another one. Yes, this one. This one. Let's. If you are done, I'm gonna change the page. By the way, there are some questions. Okay. Let's have the new page. Okay, a new question. We have an X and Y axis system here. This is X, this is Y. We have an F2 with an angle of 60, and we have one more force here, which is F3, and also we have one more force here, which is F1 for the kilogram. So the resultant force of these 3 is this is R, resultant force, and its magnitude is 10 kilograms. And the angle, this is 60. Let me write this is a midterm exam question I asked a few years ago. I'm gonna write the total text here, okay, to see what we have. 3 forces, F1, F2, and F3 are and this is point O at point O as shown. Okay, determine the magnitudes. Magnitudes necessary for F2, F3, sorry, F2 and F3 such that resultant force of R gram acts horizontally. Totally shown in the figure. Okay, this is the text of the question. In this question, we have 3 forces, by the way, at the beginning, we have to understand what we are doing. What's the question? We have three forces, F1, F2, F3, and the resultant force of these three. If we combine all these three, we get the R, the red arrow on the sketch. We get that one. So depending on given data, please calculate the magnitudes of F2 and F3. Okay, we have a resultant force, as you can see, R. So we have three forces. If we combine the X component of all these three forces, we are gonna get the X component of this R. Likewise, if we do this in the Y direction, if we combine the Y components, we are gonna get the Y component of the resultant force. Okay, let's do this. Firstly, what we have here, 1, 2, 3 forces. Let's resolve all these forces. The first one is F1. The vertical component is this. This is the horizontal component. So what is this? F1 times sine 60. So F1 is 40 times sine 60. Let's write the same equation for the horizontal one. 40 times cosine 50. Okay. Any question for this one? Can you see easily how to resolve these type of forces? Is there any question, any comments for this part? Nope. Okay. Let's use pink. Here, what we have F2. Let's do the same procedure for the F2. For the horizontal part, F2 times cosine 60. And here, vertical part, F2 times sine 50. Okay. We have all these forces at the moment. So just take a look all these perpendicular forces. Let's write the equations. So if we combine these two forces, let's do it for the X direction. Please be careful for this point. F2 times cosine 60 is in positive direction. Let's do it. F2 times cosine 60 in positive direction. So in negative direction, as you can see, minus comes from direction 40 times cosine 60. It equals what? Okay. What do you think? It equals what? Okay.
R is 10, so I think 10. Maybe. The result is.
You are right and you are wrong at the same time. It's 10. That's okay. But if you write there 10, let me write. This is the correct part. Yes, you are right for this. It's 10. But Remember, we're doing always vectorial calculation. So you have to write here the direction. If you write 10, you're gonna get wrong solution. But in which direction our 10? It's in negative direction. So we have to put here a minus. Okay, it's minus 10. Is it okay? Did you get the point?
Yeah, I get it.
Okay, okay. If you have this minus, that's okay. You did it. There's no problem. This is the first equation. From here, in this equation, we have only one unknown here, which is F2. Let's the solution here, if you solve it, F2 is, let me check the results. Yes, 20 kilograms. Let's do the y direction. What we have in y direction, we have in positive direction 40 sine 60, 40 times sine 60. Okay, so more, I have this one, F2, again positive direction, F2, which is unknown, sine 60. And also I have here F3. Is it positive or negative?
Negative.
Negative, yes. Equals what?
0.
Yes, 0. We have a resultant force on x direction. That means there is no y component of this resultant force. You are right. This combination is going to be 0. So in this equation, we know this. This is 20. So if we solve it, we have only one unknown, F3. You can get it easily. F3 is, let me check. Yes, F2 is 20, F3 is 51.96 kilogram. As you can see, the question is really basic, easy. But you have to watch out all these directions. Okay, you have to be careful on these directions. Keep in your mind, we are working on vectorial stuff. We are doing vectorial calculation. That's why we have to consider directions. If you don't do that, you're gonna get wrong solution. Okay, any questions so far? Nope. Okay. Let me check another question. Yes. New page. Please take your own notes. If you watch only, it's like a Netflix series. Okay, you are gonna watch this a few times, but you will not understand anything. Please take your notes on time. Okay, again, watch the recordings, that's okay. But the most valuable one is your notes while you're studying for the exam. Okay, we have again an XY system. As you can see, XY system. The forces are here. We have a 5 ton here. Angle is 60. There's one more here, 20. And here is the angle 45, and the resultant force, let me draw it in red. The resultant force is in this direction. This is R. Okay, 10 ton. The angle is this. This is the angle, and I have one more force. This is F, and the angle is theta here. This is the point 0. Okay, and let me write the text here. Determine the magnitude and direction of F, so that the resultant force R shown in the figure has a magnitude of 10 tons. Okay, this is the question. Again, we have a force system. We have 3 forces, and if you combine these 3 forces, we are going to get this R. As you can see, the direction and the angles here. But the question here is, what's the magnitude of one component, F, and what's the direction? That means, what's the angle of this F? The question asks theta. What is theta? What is F? What is theta? Okay. Here, by the way, can you hear my voice? I guess there is a problem on my headset.
No, we can hear you.
Okay. Okay. Sounds good. Let's take a look all these forces. We have these forces. Let's resolve all these forces one by one. If we have a force system, the first thing is resolve all these forces. I have orange. Yes. Let's write here first. 5 times cosine 60 here. 5 times sine 50. Okay, this is the first one. Let's use pink. Here we have 20 times cosine 45. Here 20 times sine 45. And also we have same components for F. Let's change the color. For example, let's do blue. Okay. F times sine theta, F times cosine theta. Okay, we have a resultant force. At the end of the day, it's a force, a vector. We have the components for this resultant force here. By the way, be careful about the angle. Angle is here. Given angle is here. So the cosine side is this, the vertical one, and the sine is this. So if we write these magnitudes, r times cosine 60, or let me change this r. Let's write here 10. We know the magnitude is 10. 10 times cosine 60, and here 10 times sine 60. So we have the all these components. Let's do it now. Let me write the results here. That's okay. Let's write the vertical direction, or first
Hocam,
horizontal.
I couldn't
Yes.
understand the last part.
Which one? The R
Yes.
part. This one. Okay. Which part didn't you get?
Why did we write cos 60 in that direction?
You were anticipating the sine right here, sine 60.
Yeah.
Okay. Let me change the color. This one. That's better. The angle, given angle is here. Okay. If you use this angle, this one, you are right. This is 30. This part is cosine 30. This is sine 30. But the angle is this. I always suggest you don't memorize the questions. Okay, take a look at the location of these angles. We have this angle, 60. So this is the cosine. As you can see here, if we have this 60, here is the cosine part, here is the sine, right?
Mhm.
But it's same for this one. This part is cosine, the neighbor edge is cosine, and the opposite, this side is sine. That's why
Mhm.
we are using this. Okay, we are,
Thank you, hocam.
okay. The rule is same. Just watch out the angles. Okay, the rule is same. Okay, let's write the equations here for the x direction. X direction. What we have in the x direction? In positive direction, we have 5 cosine 60, and these are in positive direction, plus 20 times cosine 45. Okay, and here I have minus f cosine theta, minus, because in negative x direction, f times cosine theta, 1, 2, 3, 3 components, equals what? Equals 10 sine theta, the x component of r, which is here, this one. Oh, sorry, this one. But again, be careful here. It's in negative direction. You can see here, this horizontal component goes the negative x direction. That's why we have this minus here. Okay. So this is the first equation, and let's do the second one. Let's write the y direction. We have in y direction f sine theta, plus in positive direction 5 sine 60. In negative direction, I have this one, minus 20 sine 45 equals what? This part. 10 times cosine 60. Is it positive or negative?
Negative.
Yes, you're right. It should be negative. Okay, if you write these two equations, okay, that means you solve all the question. I think you can write it easily. There is no problem. But the main thing here is directions. Directions, okay. So, let's carry on here. Let's have a look at the first equation. The unknown here is this part, the totally unknown, right? We don't know what is this. This is a multiplication, so this is a number, but we don't know this one. So the other stuff is known, so we can solve. If we solve this equation, what we are gonna get? We are gonna get this cosine theta equals, let me check the result. Please do all these calculations by yourself with using your calculators. Okay, these cosines, sines, everything. Okay, this is f cosine. From here, we have one more unknown. We can get the f sine theta. If we take all these numbers other side, you can get this. It's easy. Let me check the result. Here, 4.81 ton. Okay. We have the sine and cosine components of f, right? Now, the question is not the sine component or cosine component. The question is f. What is the magnitude and what is the angle? That means direction. I mean, so if we write these equations here, let's have a look. All these equations. Okay. What can we solve here? What can we get from these two equations? So we need to calculate f, and also we need to calculate theta. Okay. But we have, yes, you're right. We have two equations, two unknowns. We can solve it. How? Any idea?
Calculate tangent.
Yes, you're right. The basic method is that, to calculate the tangent. If we divide this equation to other one, let's do it here. In the left-hand side, we can cancel these numbers and we will get tangent, right? At the left-hand side equals right-hand side. If we divide this number to this, let me check the results. The result is tangent theta is 0.19. That's okay. If we have the tangent theta, if you do the arctangent with your calculator, tangent power -1, you can get theta. Theta is 10.76 degrees. So if you have tangent, sorry, the theta, that's okay. You can calculate the f from one of these equations. Take this, put it here, calculate the sine, and get the result. And the f is here. $25.76 tons. Okay. Okay, any question for this example? Is there anything you didn't get? If you have, please ask. Okay.
You explained very well, Hocam.
I will solve one more question in the second session today. I'm gonna do examples regarding the support reactions. I'm gonna give you, remember the last week we talked about the support systems, support reactions, and the force types. I'm gonna give you different force systems or structural systems and ask for the support reactions.
Can
Okay.
I ask something?
Let me write one more question. Yes, this one. Okay. Actually, I'm asking the same thing in different questions, but in different ways. Okay, that's why I'm solving all these problems. We have a poll. Thing on the ground here. On top of this pole, we have 3 ropes. One is this T1, 5 tons. Slope of this E4 and the other one T3, this is T2, T2. And here 4, 5, 12. Okay, the slope of these ropes are given with these numbers. Okay, here this is T2. Let me write the text. 3 forces are on current. This is O. Point O. And the tension cable T1, 5 ton. With shown necessary. X down. Okay. Here, the question is what's basically what is T2 and T3? But to solve this problem, you have to read the text to understand what we have. Okay, when we have a look at the sketch, you can see T1, T2, T3. Okay, that's okay. But what? What we have? What's the resultant force here? It's not given on the sketch. Why I'm solving this problem to you here? Please, when you get a problem, please read the text. I know most of you doesn't take a look at the text directly, take a look at the sketch to understand what is the question. Please read the text given. Okay, that's important. If you don't read and understand the text part, you can't solve the problem. So here, as you can see, the resultant force is given in the text because this is not a force system as the previous examples. Okay, we have 3 forces at the top of the pole, but the resultant force acts on the pole and goes downward according to text here. Resultant force 10 acts vertically down. It goes down here. This is the resultant force 10. Okay. So if we have this, yes, of course, we can write our equations, but beforehand, what we are going to do, we are going to resolve all these forces one by one. That's the rule. If you get a sloped force, directly resolve it. Okay, after that, you can think what I'm going to do. Okay. So let's start from T1. T1 is, by the way, you can see the slopes here. These numbers are proportional with these numbers. So 3, 4, 5 triangle here. This is 5. So this is the slope is 5. So the magnitude is 5 here. So basically the horizontal force is 3 and vertical force is here 4. And let's change color, purple. What we have in T2, 5, 12, 13. So we can do this. This component is how we can calculate this component. Okay, we have a T2 is proportional with 13 divided 13 times 12 and same is for horizontal component. So 5 times T2 over 13. So this is, these two are for T2. Let's do T3. T3 here. Let me write T3 here and here. Okay, I know all these forces are acting to this point, but they're gonna mix them each other. That's why I write the T2 here. T2 here, 4 T2 over 5. And then 3 T2 over 5. So we have all the lateral and vertical forces. Now we are gonna combine the horizontal force, then vertical. Let's write the equations. The horizontal one, what I have in the horizontal direction, in positive direction, I have 5 T2 over 13 plus 4 T3 over 5. In negative direction, I have 3 minus 3 equals 0. This is the first equation. In the second equation, which is in the vertical direction, let's write all of them. These forces, as you can see, this is negative, right? Minus 12 T2 over 13. 13 minus 3 T3 over 5. Okay, what I have more here in negative direction, I have 4 minus 4 equals what? What do you think?
I 10.
Equals what?
And minus 10.
In the first equation, as you can see, it's equals 0. Why? The resultant force is in the vertical direction. So there is no x component of the resultant force. That's why it's 0. It's like the question we solved previously today. There is no horizontal component. That's why it's 0. Here in the vertical direction, we have 10 tons. 10 tons in the negative direction. It's in the negative y direction. So this will be minus 10. Okay. So what we have now, basically, we have two equations, two unknowns. Can you solve it? I guess yes. Basically, do the algebraic calculations, mathematical calculation, and solve it. There is no sine, there is no cosine here. Do it directly. You have your calculators. So you can get T2 and T3 here. And this is the result. Okay. Any question for this? Any comment? Anything else? No. Okay, guys. Let's have a break. Okay, let's have a break first, and then half an hour. It's 11:15. Let's start the second session at 11:45. Okay. Okay, see you guys. Share. share my screen. Whiteboard. Next. Okay. Let's get started with a basic question at the moment. This is the first one. So we have a beam. On the beam, we have three point loads. Here you can see 1, 2, and 3. This is 2 ton, 3 ton, and 4 ton. And the spacings are equal to each other. 1.5 meter, 1.5, 1.5, 1.5. So totally we have 6 meter. The question is support reactions. Okay, what are the support reactions? Okay, if we have a structural system like this, we have a beam here. This is what kind of beam? Maybe you can remember from the last week. This is a simple beam. Simple beam, basit kiriş in Turkish. When we get a structural system, firstly, we are gonna put the unknowns, support reactions to the sketch. After that, if we have any distributed load, we are gonna convert it to point load. Okay. After we complete this part is a kind of preparation to calculations. Firstly, we're gonna do all this and then start the calculation, right? So here we have 2 supports. Let's think about this is A, this is B. What kind of support are these? This is a pin support. If we have pin support, that means we have 2 unknowns. The first one is the vertical one, vertical A. Other one is horizontal one, HA. And for the second one, we have a roller support. Remember this representation. This shows us this is a roller support. So we have only vertical unknown, which is vertical support reaction, which is VB. So let's check the forces. Do we have any distributed force? No. All our forces are vertical. So let's write the first equation. Total X equals 0. What I have here in the positive direction, HA here. Anything else on the beam? No, there is nothing. So HA equals 0 here. Okay, we know this one. So we have vertical A, vertical B. We can write total M B. For example, if we take the moments according to this point, so we can calculate this vertical A. Total MB equals 0. So here, let's write it. Vertical A times 6 meter. The vertical A rotates the system in this direction. Okay, 2 times, this is in negative direction, minus 2 times 4.5. Then here again, negative direction, 3 times 3 meter, and negative direction again, 4 times 1.5 meter equals 0. So if we do this calculation, let me check the A. We have only one unknown. Vertical A is 4 ton. Okay, let's write the equation for total MB. After this, what we have? I have one. Remember, what are my equilibrium equations? Total X 0, total Y 0, total M 0. So I did this one. I did this one for this one. We have total Y. If you like, you can write total Y and then get the solution. That's okay. There is no problem. But what I suggest you here, okay, I use total MB equals 0. I take the moments according to point B and calculate vertical A. And in the next stage, I'd like to do total MA so equals 0. Total MA equals 0. And then calculate vertical B. At the end, to check my calculation, I'm going to use total Y 0. If after I calculate all these unknowns, all these support reactions, if I use the total Y equals 0, and if I get the solution 0, yes, I did the correct solution. If there is something wrong here in the check, so I have to check all my calculations again. Let's do it together. We will see how I do it. I generally use the moment equation to calculate the support reaction. Firstly, we use total MB. Now I'm going to use total MA here. I will change my color here. Okay, vertical B. Vertical B times 6. So that means I assume this direction positive, the vertical B direction. But all other forces rotates the system in negative direction. Minus 4 times 4.5 meter. Then minus 3 times 3 meter. Minus 2 times 1.5 meter equals 0. So if we solve this equation, vertical B equals 5 ton. Okay, I have. Oops, there is a problem on my battery, I guess. Just a second. Okay, I solved the problem. Okay, here what we have, we have vertical A and vertical B. Did we solve the problem? Yes, we have all the support reactions. Support reactions are this one, and this one. Okay, what I suggest you to check your calculation, because you're using calculator, you can push a wrong button, you can get a wrong solution. That's why I always suggest to do a check. Myself, in my calculations, I do it. I check myself. What's it? Check. I use total Y equals 0. Okay, now we know vertical A, this is 4. 4 ton. Vertical B is now 5 ton, according to our calculation. Let's check it if it's correct or not. Total Y is 0. Total Y. Vertical A goes up to positive direction. 4. Then we have 2 tons in negative direction, 3 ton negative direction, and 4 ton negative direction. Then we have vertical B in positive direction. If we do this calculation, check it, 7, 9, and 9, the result is 0. So that means the support reactions I've recently calculated are correct. Okay. This is correct. Any questions so far regarding the question, regarding this example? No. Okay, let's do another example. This is really basic one. Now, let's change a little bit the form of the question. What I have here, let me take a look. Okay. Here we have a cantilever beam, and on this cantilever beam we have a uniform distributed load and at the end of the cantilever we have a point load which is 2.5 tons, and this is 1.8 ton meter. Here two meter, 1.6 meter. Okay, this is my beam. So the question here is the support reactions again. Okay, what was our rule? Remember, when we get a structural system, firstly, we are going to we have to calculate we have to put the unknowns, which are the support reactions, okay, to the sketch to understand what we have. Let's do it beforehand. Here, what kind of support I have? Here we have a fixed support. This end, the right end is free end. The left end is fixed end, fixed support. So we have 3 unknowns. Remember, you have to know the number of the support reactions depending on the support type. Okay, we have here a vertical reaction, a horizontal reaction, and also a moment, MA. Okay, this is the first step we have to do. Did we put all unknowns to sketch? Yes. In the next step, we are going to take a look to loads. Is there any distributed load on the structural system? Is there any here? Of course, we have a uniform distributed load. We have to convert it to concentrated load. Okay, if we have uniform distributed load, how we convert it to the point load or concentrated load? Basically, this is our uniform distributed load. The concentrated load will be at the midpoint of this one. So this is my concentrated load. To calculate its magnitude, basically, we calculate the area of this rectangle. Basically, the area. Area is 2 times 1.8. It's 3.6 ton. Okay. This is the new point load. Okay. I've just converted it to point load and then I'm done. Now I can take this forward and make the calculations. Okay, here, let's write the total x 0. Total x is 0. In x direction, I have only HA here, HA in positive direction. Is there any other on the beam? Anywhere else? No. So if total x is 0, HA equals 0. There is no support reaction in horizontal direction, that means. Okay, let's do the total y equals 0. Here, what I have, vertical A in positive direction goes up, and here minus 3.6 goes down here, and minus 2.5 goes down here, equals 0. In this equation, we have only one unknown. As you can see, it's easy to get the vertical A, VA. VA is here 6.1 tons. Okay, we have HA here. Now we have point A. We're gonna write total MA equals 0. Total MA. So let's write the equation here. Let's start from this point. 2.5 times distance. Distance is 3.6 meter. Rotates in this direction. Let's say this is positive. Then this one plus 3.6 times here is the distance 1 meter. Remember, this is the midpoint of this rectangle. Total is 2 meters, half is 1 meter. Here, 1. Okay. And minus MA equals 0. So what we have here, MA, if we do this calculation, MA equals 12.6 ton meter. Okay. Now we have all the reactions, HA, VA, MA. When you get the problem, you need to understand how many support reactions you have to calculate. If you don't know that, you can't calculate anything. You have to put the correct reactions to the correct supports, then do the calculation. The calculation part easy, not so difficult. Just give your attention to question and do it. I know you can do it easily. I have any question?
Professor,
Yes, please.
in the diagram, I guess 1.8 should be 1.8 ton instead of ton per meter, right?
Sorry, one point.
1.8
Yes.
ton instead of ton per meter, right? Because it's not the moment, it's
You are talking
yes,
about this one?
this one.
Yes, this is a distributed load. That's why
So it's per meter.
it's per meter, yes.
Correct.
At each meter, we have 1.8 ton. So what we did, we converted to a concentrated load.
So it become per
Yes.
ton. Okay.
But here, while we are converting distributed load to concentrated load, two things are important. One is the magnitude of the concentrated load. That's okay. And its location. Its location important because we are going to do a moment calculation. So the distance is important for us. Okay, let's do one more question regarding this. I'm going to start on the next page here. Okay. Let's do, actually, I don't have any example like this, but I'm gonna write a question here in mind. I don't know the result at the moment, but no worries, we can calculate it. We can put here triangle distributed load, and this is 2 ton meter, and here okay, this is here, this 1 ton meter, 2 ton meter. This is 3 meter, let's say. This is 2 meter and 1 meter spacing. And also there is here one more concentrated load at the midpoint of this one. This is 5 ton. Okay, here is 1 meter, 1 meter. Okay, this location. Okay, this is the question. Here we have a beam system. On the beam system, we have triangular distributed load, uniform distributed load, and there is one more concentrated load at this point. What are the support reactions? Again, the question is. Okay. Okay. What is the rule? What are we going to do first? We are going to put the support reactions we are looking for to sketch here. Let's say this is A, this is B. Vertical A, this is pin support. And we have 2 unknowns. And here we have a roller support. We have 1 unknown, vertical B. Okay, we have just completed the support reaction. Let's do the uniform distributed loads. Okay, remember we have a triangular distributed load. how we can calculate the magnitude of this triangle? Any idea? The idea is same. The logic is same. For each type of distributed load, calculate the area, basically. Calculate the area that gives us the magnitude. Here we have a triangle, 2 times 2 over 2, right? Because it's triangle. So it's 3 meter, 3 tons, sorry, 3 tons. So the location is important. Location is over here. This is 3 tons. How we calculate it? 2 times 3 over 2. This is 3. Location is important. We are going to use the 1/3 rule. From the highest point, we will go 1. The total, we will assume this is total is 3, and we will go 1 from the highest point. As you can see here, this is 3 meter. It's proportional to 3. So this is 1 meter. Here is 2 meter. Okay. Now we have a concentrated load here. Let's have a look at this uniform distributed load. We have this rectangle here. Let's calculate the area. 2 times 1, 2 ton, 2 ton. That's okay. Where is the location? 2 ton. This totally 2 meter. Since this is a rectangular shape, so it's gonna be at the midpoint. Let's put the 2 ton here. In the question, at the same point, there is one more concentrated load, which is 5. Okay. Totally, we can say 7. Did you get the point here? We have 7 here, totally. Okay, now we've just converted all the distributed loads to concentrated loads. We can step 1 forward. What we are gonna do here, we're gonna do our calculations. Let's get started with horizontal.
Hocam buradaki 3'ü nasıl bulduk? Ben o kısmı anlayamadım.
3. Bu mu?
Evet.
Okay, we have a triangular distributed load, right? So if we have triangular, if we have actually, don't think about the shape. If we have distributed load, to convert it to concentrated load, we calculate the area. Look at this one. We have a triangle. So as you can see here, this dimension is 2 times 3 over 2. This is triangle because so the result is 3. Is it okay?
Yeah.
We did same for this uniform distributed load. So basically it's a rectangle. 2 times 1 is 2. I put it here. At the same point also I have in the question, I have 5 tons, totally 7. Okay, now let's write the equations. Total X is 0. Total X, this is HA. Is there any other lateral load? No, HA is 0. Okay. Let's write the total MB. I'm going to use the moment equations to calculate vertical A and vertical B. And then at the end, I will do total Y equals 0 to check my calculations. Total MB, V equals 0. VA times totally 6 meter. This is positive now. Here I have 3. It's in negative direction. 3 times what? 2, 3, 4. 4 meter. So come here again, minus 7 times 1 equals 0. Okay, I'm gonna calculate it. I have my calculator here. I will do it with you because this is not a ready question. I just wrote this my mind. 7 plus 12 over 6. Here, VA is 3.17 ton. Let's write total MA. So the point A is this. So vertical B rotates the system in this direction. I'm going to assume this direction positive and the others are in negative direction. So here, vertical B times 6 minus 7 times 1 to 5, right? 1 to 5, 5 meter, 5 meter. And then I have 3 times 2 meter equals 0. Here we are gonna have vertical B. Let's do it. 35 plus 6. Okay, this is vertical B. Okay, I need to check if I'm correct or wrong. Here, just a second, I need to check something. Okay, share my screen again. Total Y, check. Is here. Now, actually, we have just completed the question. We have all support reactions, but I need to know what I'm doing. Check total Y 0. Let's do it together. Vertical A in positive direction, 3 in negative direction. Come here. Totally 7 here goes down negative direction, and vertical B goes up. Equals 0. So here, vertical A plus vertical B must be 10 in my calculation. Let's check it. Is it 10? Yes, it's 10. So my calculation is correct. Any questions so far regarding the calculations, reactions, or anything else? We have time. I'm gonna solve a few more questions for you. Yes. Let me check another question. So what's it? Okay. One more page.